Hello and welcome. In this video, we're going to look at how to use the probability calculator in Geogebra to calculate or find the z-score for given areas or regions of the normal distribution. So really, these types of questions will be giving us the area, and we are being asked to find the score or the z-score or the data value. So without further ado, let's get into it. We've got a couple of examples here where we are given graphs and areas. If you're using the app-based GeoGebra on either an iPad or an iPhone or an Android phone, and you are trying to use this, make sure that you download the GeoGebra Calculator Suite from your App Store. The symbol is the pentagon as for the O in GeoGebra. If you download just the graphing calculator, you're not going to be able to have this, and you'll have to download a separate app. So I'd recommend doing that. If you are using the web-based GeoGebra, which is what I'm using, geogebra.org/calculator, you can switch between the calculators, and we will choose the probability calculator. Again, if you're using the GeoGebra Calculator Suite app on your mobile device, you can just click the hamburger or the three lines in the top left and switch between calculator or graphing rather and probability. All right, so GeoGebra is nice because we can just choose the type of shading that we want, and the graph will follow with whatever it is that we're doing here. So we just need to match the shading to the shading of the picture. It asks us in part A to find the z-score for the shaded area or probability given. In this case, we were given that the area to the left of some unknown z-score is 0.1466. I'm going to estimate the z-score to be about negative 1.05. We don't need to worry about approximating it, but it's helpful to do this so we make sure that we're doing the right thing and so that we can confirm that our answer is going to be accurate. For all of these examples today, we're going to be using the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. The standard normal distribution is basically what happens when we standardize all of our values by using z-scores. There's other videos in my channel that show how to find z-scores, calculate the z-scores, and also there's a better explanation as to why we use z-scores for these. But for right now, we're just going to do a bunch of these examples together. So we want to find the z-score or the x value based on the given probability or based on the given area. So what we will do here is we will put our area as the answer in GeoGebra, and this will give us the z-score on the inside. So for this first example, our z-score is actually negative 1.05. Just in case you missed that, basically what I did here is using the probability calculator, we can choose normal distribution, which we're using. We don't need to worry about touching the cumulative. Make sure that we shade to the left because the graph is shaded to the left. The mean is 0, the standard deviation is 1, and we're going to type our area into the solution area region of the GeoGebra calculator, and our answer for this question will come from inside the parentheses. In a way, we are working backwards. In the Casio calculator and the Texas Instrument calculators, which there are videos for those as well, we use the inverse normal function to answer these questions. So we're basically doing the same thing here. Now for part B, we can solve this in two different ways. One way that we can do this is, well, we know that the area is 0.200, and we're told that it's shaded to the right based on the picture. We can just make the graph shade to the right and put in 0.200 for our area, and we will get the z-score of 0.84. The second way we could do this is, well, if we know that the area to the right is 0.200, then we know that the area to the left, the complement of it, would be 1 minus 0.200, or 0.8. So I could have just done, for my left shaded region, an area of 0.8. And we got the same z-score of 0.84. Part C, again, is pretty straightforward. Shaded to the left. Area is 0.7673. So we're just going to type in the area region, 0.7673. And we'll get a z-score of 0.73. Again, just taking the z-score, the x value from inside the parentheses here. We're working backwards. All right, so now Part D is going to get a little bit complicated. In Part D, I have essentially 3 different shaded regions. I have the blue shaded region, which I am shading now. We have the purple shaded region, which is given as 0.1808. And we have the, let's go with, I don't know, we'll go with red, reddish. We'll have this red shaded region. Now this red shaded region, I don't know the area. The area is unknown. But we can work to find it. First thing to notice is that there are 2 bounds of my purple shaded region. There is a lower z-score and an upper z-score. My lower z-score, which I'll write over here, would be like my lower z-score is going to be 0 because that's just the way the graph is drawn. I know that the z-score 0 is the lower bound. We don't need to do too much calculations or worried about that one. For my upper z-score, though, that's what we don't know. My upper z-score is what we're trying to find. So there's 2 ways of finding this upper z-score. The first way of finding this upper z-score is to identify the area to the left of it. The area to the left of this upper z-score. Well, the nice thing about this graph is that a z-score of 0 has an area of 0.5. And my purple shaded region has an area of 0.1808. So the total to the left is going to be 0.6808. So I can just put in 0.5 plus 0.1808. Or if I wanted to, I could just add them together off on the side, and that would be 0.6808. And I'll get that my z-score, my upper z-score is 0.47. But I also could find the area to the right of this value. If I wanted to find the area to the right of this value, well, I could use the complement. I could find this in 2 different ways. The first way is that I know that 1 minus 0.6808, which comes from the sum of these 2 values, would be everything to the right of that orange line. Well, for this, to do this in GeoGebra, we need to go back to the regular old graphing calculator, and then we can type in 1 minus 0.6808, and we'll get that this region here is 0.3192. But I also could instead, if I know that z-score of 0 is my lower bound, I know that I could also do half of the graph minus 0.1808. So kind of forgetting about the left side of this graph and just using 0.5 minus 0.1808. And I'll get the same area of 0.3192. Going back to the probability calculator, I could have done this the same way by typing in 0.3192 for the right shaded area to get the same z-score of 0.47. So I only went through that so that we can work with future questions a little bit easier. Parts E and F, E will be straightforward. F is going to be a little bit more complicated. For part E, we're given that the right shaded region is 0.025. So I'm just going to choose the right shaded region and type in that the area is 0.025. And we'll get a z-score of 1.96. For part F, there is no easy way of doing this in GeoGebra. We're going to need to do a little bit of calculation and a little bit of figuring things out for this one. So, similar to what we did for part D above, we have three distinct regions. We have the purple shaded region, which is 0.7887. We have what I'm going to color in as the blue shaded region, which is everything to the right of that in the right tail. And we'll have what I will color in orange right now, which is the lower shaded region, everything to the left of this. What you'll notice is that these two z-scores, wait a second, hold up, there are two z-scores. There's going to be a lower z-score and an upper z-score. This solution will have two different values, but what you'll notice about them is that they are approximately the same, meaning that this is a symmetric graph. So the area to the left of 0 and the area to the right of 0, or the mean, is going to be the same for both. So once we find one z-score, we'll have both of them. But we're going to go through the same process for future examples as well. So I'm going to go through this one in nice slow detail. So if we know that the middle of the graph is 0.7887, that means that the lower area, or the left area, plus the 0.7887 plus the right area has to equal 1, because the total area under the curve is 1. If we wanted to do a little bit of algebra, we could subtract 0.7887 from both sides. And we'll see that the left area plus the right area should equal whatever 1 minus 0.7887 is. In GeoGebra, we can click on the hamburger, switch calculator back to graphing, and we can do what we were talking about earlier, which is to find the complement. 1 minus 0.7887, and we'll find that the two areas together will add up to 0.2113. Now, since this graph is symmetric, each of these regions will be the same. So if we divide this by 2, 0.2113 divided by 2 will be 0.10565 and 0.10565. So just a quick recap. We know that the middle area is 0.7887. It's given in the graph. If we want to find the area in the tails, we can subtract the middle from 1 to find the complement. We know that the two tails combined will have an area of 0.2113. So dividing that in half, we'll find the area of each tail. Now we can use those areas to go back to the probability calculator and type in for the left tail an area of 0.10565, and we'll get a z-score of negative 1.25. And then if we type in to the right area an area of 0.10565, we'll get a z-score of positive 1.25. Again, we're looking for two different values, a lower z-score and an upper z-score. I know this video is getting a little bit long. I have 4 more examples I'd like to show, and then we'll be done. So the next 4 examples are very similar to what we were just talking about. The only difference is there are no pictures drawn. So I'll be sure to draw pictures for each of these. Again, I personally am a visual learner. I like to look at what it is that I'm trying to solve. So that's what I'm going to do here. The question says, for a normal distribution, so that's why I'm drawing the bell-shaped curve, find the z-score or scores that cut off the given areas. For this first one, it's asking for the lowest 20% of the area. The lowest 20% of the area is basically asking us to find a percentile rank. Recall that percentile rank is the percentage of values that are to the left of some given value. Well, if we know that there is some value that cuts off the lowest 20% of the graph, we're essentially looking for the 20th percentile. Since we're shading to the left, we're looking for the left bound here. We're going to choose the left shading in Geogebra, and we're going to make the area, I'm going to double click here, 0.2. And we'll get that the z-score is negative 0.84. For part B, it asks for the highest 10% of the area. The highest 10% of the area would be way over here, which is essentially asking us to find the 90th percentile. Doesn't really matter if we think about this in terms of percentiles or not. I'm just trying to build the framework for future examples where we'll deal with percentiles. But for right now, we're just going to choose the right shaded region and change the area to 0.1. And we'll get that the z-score here is 1.28. Now, for part C, we're being asked to find the middle 90% of the area. The middle 90% of the area is approximately there. So if we're looking for the middle 90% of the area, well, that means that, give me 1 second. The two tails of the graph will be 10% of the area. Right? 100 minus 90 would be 10%. So each of these regions would be 5%. And as a decimal, it will be 0.05 for both green shaded regions. I'll zoom in a little bit. Well, if I wanted to find the lower z-score, again, if we're trying to find the middle, we're trying to find between two values. The lower z-score will have an area to the left of 0.05. 0.05. That will give me a lower z-score of negative 1.64 or negative 1.645. Now, I can just change this to the right and make the value, 0.05, and I'll find that the upper z-score will be positive 1.645. Just really quickly trying to lay the ideas for other types of examples we could have. We could have also used the area to the left of 0.95 to get the same z-score. If I typed in 0.95, I'd get the same z-score, 1.645. Right, and the last example, again, I apologize, I know this video is getting kind of long, but the last example would be pretty quick. If we're trying to find the middle 50% of the area, something like this, the middle 50% would give us that there are 25% in the lower shaded region and 25% in the upper black shaded region. So like the two tails of the graph would be 25%. Essentially, oops, my apologies. I leaned on my keyboard there. Essentially what we're looking looking for is the first quartile, or the 25th percentile, and the third quartile, the 75th percentile. So we're trying to find what value or what z-score will give us the lower 25% and what z-score will give us the upper the upper 25% or the lower I said that wrong. The upper 25% or the lower 75% or the third quartile. So we can just type in 0.25 and make sure it's shaded to the left. We'll get a z-score of negative 0.67. We could change this to the right and make this 0.25 and get a z-score of 0.67. All right, so that's how we can use GeoGebra and the probability calculator in GeoGebra to find the z-scores for given areas based on the standard normal distribution. Thanks for watching.